Right, welcome to FMGT 3224, Lecture 7, Part 3. We are in the process of doing a direct materials variance calculation. We've got our three columns kind of set up here, and now we're all set to do some comparison. And so, use black for this. The difference then between 342 and 360 and 360 and 336 turns out to be a whopping, not dollars, $18,000 favorable variance between these two here, right? So we are paying less. If we were to do the math and figure out what this amount here was, we would discover it would be something less than 8. So we have a favorable price variance. But we can tell that here we have an unfavorable quantity variance. We should have used 42,000, actually used 45,000, and that cost us 24,000, and it was unfavorable. So quantity variance. So, you know, as we look at this, okay, we got some cheaper material, but it turns out we had to use more of it to achieve the same level of output. Is that a plausible explanation? Yeah, it kind of makes sense. I mean, in total, we're only out 6,000 RM, but we, well, you know, once we break it into our different components here, you know, maybe the purchasing manager here, someone's planning to give him a bonus because he spent less money, and someone's planning to ream out the production manager, and it turns out that this guy did the best he could given the crappy stuff that this guy bought. You know, who knows, right? Again, you can't draw final conclusions from this. You can only identify where you need to go look and figure out what's going on. And just because a variance is favorable doesn't mean you can ignore it, right? It can be favorable for a bad reason. In this case, this is one example, right? He bought crappier stuff, possibly. So any big variance typically should be investigated. Sometimes, you know, it's someone's favorable variance is caused by someone's ingenuity, and you want to replicate that throughout the rest of the organization if you can. So lots of different reasons to investigate favorable variances as well as the unfavorable ones. But that concludes the exercise. Let's carry on with the rest of the lecture. Okay, so what now then we're going to look at is one slight nuance to do with direct materials, and that is what happens when you buy quantity X, which goes into your raw materials inventory, but you don't use the exact same quantity in production. So you've got a different quantity purchased from the quantity used, because as you, if you'll recall, this assumes the same quantity in both cases. So what do? Well, we compute the price variance based on the quantity purchased and the quantity variance based on the quantity used. Fairly logical. Okay, what does it look like in practice? Well, let's go back to our zippy thing here. So we bought 2,800 kilograms, used 1,700. We do the price variance first, and then we'll use the do a quantity variance second. And notice then that if you were going to put the two of them together, you'd have this price variance up here, and then sort of lower down, you would rewrite this information using the 1,700 kilograms at 4 kilos per bag, and so on down here, and that's how you would end up doing it. And you'll see examples of this in the homework problems. Okay, so again, Use the quantity purchased for the price variance, the quantity used in production for the quantity variance, and you're good. Okay, so now, who's responsible for the variances? Well, as we've talked about, first we'll go with the disclaimer at the bottom of the slide here, right? These, you have to be, you got to be a little bit careful not to use the variance as a reason to go out and hang somebody. It should give you a starting point for your investigations, trying to figure out what's going on and why. So, ordinarily speaking, in a materials price variance, it's whoever goes out and does the buying, right? So, more than likely, that would be the purchasing manager. The quantity variance, though, is more the people running the production aspect. And so those would be kind of the default positions of responsibility for these two kinds of variances. But again, got to investigate more to figure out what the real underlying reasons are. Okay, we've done materials. Now let's look at labor. Again, same kind of thing. Going back to our Hansen company and the Zippy stuff, we've got a standard for labor, 1.5 hours at $6 per hour, and so on, and then some actual data. What does it look like? Same model, actual quantity, actual price, okay, hours and rate, but same thing if you think about it. Actual hours, standard rate, standard hours, standard rate, and so on. Notice then that we have some slightly different names for these variances. Instead of a price variance, it's called a rate variance. When we talk about labor, instead of a quantity variance, it's called an efficiency variance. But you know what? They're the same thing. So don't get hung up on the terminology on the labels that we hang on these things. You've done this this sort of stuff before. We're not going to belabor this point too much. We're just going to head straight into an example. So hit pause, break open your book. Take a crack at brief exercise 11-3 and then come back and check your solution against mine. Right, so Air Cooks prepares in-flight meals for major airlines. One of the company's products is grilled salmon and dill sauce with new baby potatoes and spring vegetables. Sounds good. During the most recent weeks, the company prepared 4,000 of these meals using 960 direct labor hours. They paid the workers $9,600 at $10 an hour. Standard cost should be a quarter of an hour at a cost of $9.75. Number one, how many hours should have been used and what direct labor cost should have been incurred to prepare the 4,000 meals? And how much does this vary from what was actually incurred? What is this variance called? Okay, so 4,000 meals, which should take 1/4 hour each, means that it should have taken 1,000 hours, or direct labor hours. DLH. And what should that have cost us? 1,000 direct labor hours at $9.75 per direct labor hour means it should have cost us $9,750. It actually cost us $9,600. So we have a total direct labor variance of $150, and in this particular case it is favorable because we actually spent less than we used, or than we had planned, sorry. So number two, break the difference computed in part one into a labor rate variance and a labor efficiency variance. Okay, so again, actual quantity times actual price, actual quantity times standard price, standard quantity times standard price. Actual quantity, 960 hours. Actual price, 10 bucks an hour, 9,600. Okay. Actual quantity, 960. Standard price, 975. Do the math, $9,360. Standard quantity, 1,000. Standard price, 975. Oops, 9,750. So then, as we look at these, what do we get? So price variance, or in this case, the labor rate variance. Labor rate variance. Turns out is unfavorable, right? This is going up from 9,360 up to 9,600, $240 unfavorable, which makes sense because instead of paying $9.75 an hour, we're paying 10 bucks an hour. So yeah, that's logical. Oh, I'm gonna make my U in red just for effect here. Now, on the efficiency variance, we go from 9,750 to 9,360, so we know it's going to be favorable, and the math says it's $390 to the good, favorable. Okay, so a small overall variance, but actually a larger unfavorable offset by an even larger favorable is what gets us to this small one. So what does this mean? Well, maybe we have some more skilled people because they work faster, and in order to attract the more skilled labor, we're paying them a little bit more than what we had planned, possibly. You know, who knows, all kinds of different potential explanations for this. The key is, now you know that you got to ask some questions somewhere, find out what's going on. So that's it for the exercise. Back to the lecture. All right, so where do labor variances or unfavorable labor variances, where do they come from? What are they caused by? Could be a number of factors. These are some possibilities here. Again, the responsibility, where does it lie? Well, typically the guy or gal in charge of production will be responsible for labor efficiency, but the labor rate variance, I don't know, the HR department perhaps. I mean, whoever it is who is you know, hiring these guys and determining that they should be paid more. All right, the third and final sets of variances that we're going to look at now are the variable manufacturing overhead variances. And when we look at the two components of the overhead variances, the spending variance basically says, okay, you know, is what your actual overhead costs are higher or lower than you know, the individual items than what your standard was. But on the efficiency side, because we allocate overhead, we don't trace it directly, the variable overhead efficiency variance actually has very little to do with overhead. What it captures is how efficient is the allocation base, or our use of the allocation base. Here, what they're calling a cost driver. Right. So, if we allocate overhead on direct labor hours, then the efficiency, the overhead efficiency variance, is going to actually measure our efficiency with direct labor hours, and therefore is not going to be as useful to us in controlling our overhead. But we will get into this in more detail in part 4.